Tell me what you guys, tell me how you guys are messing around with it to figure it out. Lydia, help me.
Well, I thought, never mind. I just
No! Tell me what you're doing.
Well, I started where we left off, and then I got one decimal point.
Good for you!
And I got to 0.251, but I can't make it go anywhere.
So you went to more probs. Let me say, Lydia went to more probs. Forward. Between. What'd you put in for your left bound?
0.6777 and a lot of sevens, and then after that it doesn't matter what I put. I always do the same thing.
And then you put 0?
Yes. Except negative, sorry.
Oh, I should have put negative in. But that's close. It gives me a negative area because I put it in the wrong order. That's damn close, 25.1%. Rob?
0.6745.
More probs forward, between. 0.6745. Check you out. Negative.
Yes,
Thank you.
negative.
I'll do the same mistake again. 0. Hot damn. Now, how'd you get that, Rob? Just keep whittling away until you got it? Excellent, brother. Excellent. Now, I want to introduce you to my other part of this program I love so much. The backwards command. Did anybody mess around with the backwards command at all for this one? No. This would have been your best friend as far as backwards goes. Here's the deal. The reason I call them forwards and backwards, here's what makes it forwards versus backwards. A forwards problem is one where you know the z-scores that you want to use on the horizontal and you're trying to get the area that you need up here. That's a forwards problem. That's how I call that forwards. It's just my little term that I use to discuss. Gesundheit. We'll use it a lot more on Thursday. Gesundheit, my friends. It's statistics allergy. It's very common. A backwards problem is where you know the area and you have to find the z-score that you want to use. So everybody, if you would, go to more probabilities. Pick backwards. Now, it gives you the option to shade left or right. This seems weird. Stay right there for a second. Don't do a thing. I'm going to quit out of here. And I'm going to start up the program again. I'm going to get there. Look at the last curve we had up. Negative, was it 0.6745 you said, Rob?
0.6745.
Okay. Now, the problem is you can't put this area in. I didn't code it to let you do that because there's a reason. I'll explain why on Thursday. But if you know this is 25%, don't you also know this right here is 25%? You can use the symmetry of the curve right now. And the fact that this is half and that's half. So when your backwards right now says area shades left or right, let's tell it to shade to the left. Yeah, let's tell it to shade to the left. I'll get caught up with you guys. Still backwards. We're doing backwards. Shade left. What percent? 0.25. And what you'll see is it'll come up, shade it all, and then it'll give you the 2 decimal places, 0.67. So in other words, you don't have to whittle it down and figure it out. It'll take you right to 2 decimal places. Rob's is actually better. It's more precise, 0.6745. But 2 decimal places is enough for precision for this class. So 0.67. 2/3 of a standard deviation. How many of you guys did the Chevychev's quiz from weeks and weeks ago? A couple of you. Not very many people did. It wasn't very popular. One of the questions on there was, between how many standard deviations is 50% of the data? Well, 25% of it's here, 25% of it's here, and it's between 2/3 of a standard deviation. That's where that guy came from there. That was a little look-forward quiz if you decided to do it. Which, judging by the response, most of you didn't. That's okay. We're looking at it now instead. So, let me ask a question. What z-score over here, would be the 10th percentile? Let's bring those guys back. 10th percentile. Which means how much area do we have right here? Don't overthink it.
A tenth.
A tenth. 1/10, 0.1. That's a backwards problem, isn't it? Let's see if I drew it in the right place. It's a backwards problem. It's a backwards problem. I want to shade to the left, and I want 10% of the area. Oh crap! Nobody saw a damn thing. -1.28. -1.28. That's the z-score that separates the top 90% from the bottom 10%. The 10th percentile otherwise, right? Remember percentiles back in the day? It's the percentage that you're bigger than. Negative 1.28 is bigger than 10% of the other z-scores. Hey, don't use your technology. What would the 90th percentile be? Wouldn't it have to be positive 1.28? Because it's symmetric, yes? Doesn't that make sense? Hopefully that makes sense. If there's a 10% tail down here, that means there's a 10% tail above, which means 90% from here all the way down. Is that believable? Okay, ask me that question. It's just processing. You just make it all processing.
I'm a little tired.
Oh, I'm sorry, dude. Stop picking on you. Fair? If you didn't know that, suppose I asked you what the 90th percentile was, could you use the program to do it? Of course. More props. Backward. Area shades, your choice. You want to shade left or right?
Right.
Want to shade right? Awesome. If you shade to the right, just make sure you're going to shade 10% to the right. It's 90% this way, 10% that way, right? Come in, draw it, here it comes. Brrr. Nope, didn't quite get it right there either. And there it is. 1.28. Or you could shade left 90%, which would give you the exact same score, wouldn't it? Because if it cuts 10% off the top, it cuts 90% off the bottom. That is the standard normal distribution. Those of you sitting there going, what the hell do I care about this for? You don't right now. It's a tool. It's a tool that we're going to use to solve problems next time, like what percent of people walking around are dull normal on the IQ scale? What is the probability that a pregnancy will be induced? Any guesses on that one? Any guesses? So think about a randomly selected pregnancy. Randomly selected pregnancy. Sometimes they're induced, right? Sometimes they're induced. Assuming it's not because the doctor wants to go on a golf vacation. Suppose it's actually natural causes for safety reasons. What percentage of pregnancies should be induced?
25.
15%, 25%. What do you think? 25, 20, 20%? Janelle's saying that's too much, so you're saying 5?
Yeah.
5? Okay, 5%? 5%? Anybody have a different vote?
Are we looking at all pregnancies?
Yeah, randomly select the pregnancy. We'll go with American, make it simple, then American Oregonian pregnancies. So we got a range of values, 5% to 25%. Which one is it? We'll figure it out. We'll figure it out using this tool to approximate how many pregnancies percentage-wise should be induced. That's why you care about this. Not because this by itself is lame, but this in use. Yes. How many dull more people are walking around? Who's more impressive, Mark Spitz or Michael Phelps? Some of you don't know who Mark Spitz is. That's okay. We'll learn about Mark Spitz next time too. He's a fantastic mustache. We'll learn about him on Thursday. Okay? This is a great, he's the best. The best mustache ever. And the fact that he swam with that thing. We'll talk more about that on Thursday as well. This gives us a tool for discussion. That's all we need it for. Okay? Yes, let's figure you out, Sean. We'll see you guys on Thursday, yes? Yes.